Hello everyone, this is Hao from UI TV. Today I am going to demonstrate a list of useful functionality in UI Engine. The focus is Deb Panel. Deb Panel is available in debug build for any UI-based application by default. It is packed with many useful features for development, debugging, and testing. Let's get right into it. As you can see here, I have launched our sample application that comes with UI Engine. To trigger Deb Panel on desktop application, simply triple click top left corner. You will see a list of options presented here. On a TV device, you can simply triple click play pause button, or for game console, you can single click the right thumb button on your controller. Since this list is very long, I'll be explaining a subset of basic items shown here. The first few options are simple and used very often by React Native developers. Remote JavaScript debugging. You turn this on, it will launch a Chrome browser with React Native debugger. You can also use this option to connect to your favorite debugging environment, such as Visual Studio Code. React Native Reload. So this is the option where you can force the application to reload JavaScript code from Metro Bundler. React Information. This is where you will find React Native specific information about currently running application. Let's turn that on. You'll see a little box on the top right corner. Scene Tree Inspector. This is a powerful tool that can be used in many scenarios. First, let's turn it on. You'll notice in the top right corner, in the little window, there's many information presented. And as I hover over using my mouse, you'll see a slightly enlarged section is displayed. So in this information window on the top right corner, we can tell the name of the view, the class, the template used, the parents, position, scale, and size. So this can be used to identify the view is correctly rendered according to the specifications. Let's go back and turn on, I want to inspect now more than view, the nodes and views. So now we can find the text nodes, the names, and the class, meaning what kind of text we're using. We have SDF here. And it also can inspect the background now, the gradient-bg.png. And this is a CYI image scene node with dimensions. So this also can be a way to check the actual dimension on actual device. An interesting tool here is a large zoomed view of the cursor. If we turn this on, you'll see the top right corner, the window enlarges around my cursor even bigger. So this is very useful when designers inspecting, tiny little glitch, visual glitch on the screen. I have used this in the past to inspect visual glitch on fonts, because certain fonts have issues on certain platforms, and sometimes the font itself have bug in it. Some glyph will not render correctly in a 4K device, for example. Asset Viewer is an important tool to use when inspecting assets that is currently displayed on screen and in memory. The first thing to notice here, the graph shows how much memory is being used for each category. Texture are mainly consist of images from the web and also the local assets. Timelines and view templates are the exported file from After Effects. Buffers, frame buffers, system are the system assets such as text atlas, and shaders. Let's zoom into texture. It shows the detailed information such as file size, type, name, paths, resolutions, and the list is ordered from the largest to smallest. This is a good place to inspect if you are displaying a large image in a small container together with Scene Tree Inspector. Imagine if you have a large list which has a 400 by 300 image container. However, if you're loading a 4K image in all of them, this is the place to find the actual dimension of the file that's been downloaded. Scene Tree Viewers is another powerful tool. It displays the entire scene tree representing the current scene presented to the user. This is mostly useful when you're trying to determine if a view has been inserted correctly with their name. For example, here, the image view, which has a name of container image. Or very useful when you determine if there's a view behind another view. In here, as we can see, there's an image node here, but it's not visible to user. This means there is a view behind what's currently displayed to the user. In fact, if you look closely, the entire list is behind the current view. Log console is an on-screen log console overlay that comes to the bottom half of the screen, and these are the logs from your native application, which includes JavaScript console log as well. The reason for this feature to exist is that on some platforms there's no convenience way to get live log from target device. Therefore, this tool helps to display low-level log for inspection. View outline is probably one of my favorite tools in this dev panel. It shows the boundary of the scene nodes. Let's turn it on. So if a view or the node have a layout, on the top left you'll see a layout name. So let's take a look at this one. So it's a yoga list, which is a flat list, I believe, in this case. And each of the item is a stack layout. So when you enable this, you can actually see how complex the application is or how simple the application is. Let's go into one of the screen. So these are everything presented to the user. User also can use this to determine overlapping buttons, which is especially important in the TV applications to work with focus issues. Next, Focus Debugger is probably one of the most used tools for developer working with TV platforms. Let's turn it on. This shows the debug information for a focus node, focus route, the next focus in the 4 direction, up, down, left, right. As you can see, when I navigate around, the information updates. Since user will use remote control to navigate around the screen, going up, down, left, right, the next focusable item should be in a natural order to user. This will avoid very confusing user experience. However, as we create UI on TV, like many other focus algorithms, it is not always easy to find a visually optimal next focus to human eye. Therefore, this tool can be used to debug and inspect focus behavior. Time dilation is a tool that manipulates animation speed. Let's turn it on. Take a look at the options. There's options from slowest to fastest. Let's set it to slower. When we navigate around the screen, you'll notice the focus timeline is running at slower speed. When you're transitioning from one screen to the other, It's also running at slower speed. The purpose of this tool is to simply inspect animation at different speed to determine or debug animation glitch. In this application, the animations are very simple. The focus animation is a scale animation. The transition animation is a shift position with opacity. Imagine you have a complex animation that consists of multiple timelines. In designer's word, a recursive timeline, or developer can construct a timeline group with multiple animations. This is the tool to be used when you see animation glitches and you want to examine closely in a slow motion. Device information is all information available on this device. And by device, I mean the target device. For example, I'm running this app as a desktop application on my MacBook. I turn it on, our overlay window shows a general information of the device, You.i Engine version, and all the information about You.i Engine. Last but not least, Event Viewer opens up a window on top part of the screen. It displays all the events being captured by You.i Engine event loop. Let's go back to this screen. If I navigate around the screen, you can tell I have key press event and focus event from poster 1 to poster 2, from poster 2 to poster 3. In a mobile device, all the touch event will be appearing here too. On a desktop device, I can use the mouse to simply click a component. You can see the component have received the user input and have handled them. This is useful when you're developing and debugging a custom event handling component. And that is the end of my demo.